настраивать. Да, вроде слышно.
Раз, раз.
Тест, отлично, да.
То есть можно в два, да?
Тест.
Hello. Hello, guys. We are very happy to see you here. Thank you very much. Our company, Semrush, a digital marketing platform, loves create some events like this, some meetups, and we are very happy you here. And are you ready? Let's go.
Here we go. Can hear me now? How are you all doing? So my name is Radek Sимко. I work for HashiCorp, and you can also find me on the internet as Radek Sимко pretty much everywhere. GitHub is probably the most relevant to this talk. I work as part of the Terraform team, maintaining the provider land, mainly AWS, but I also build a Kubernetes provider, which is what we're going to talk about today. So just a quick show of hands. This is going to be a bit more intimate, which is, that's more interesting because I can get to see who uses Kubernetes. Okay, just 3 hands. Who uses Terraform? Okay, 5, 6. That's good. That's good amount. So managing a Kubernetes cluster means managing a few different layers to me. So let me decompose the whole thing into 3 layers. First, we start with something I call base infrastructure. That's depending on where you run, that could mean something like iPXE, your network, your firewalls, EC2, VPN, CDN, etc., etc. And then on top of that, you expose some kind of interface through operating systems, like your favorite flavor of Linux. And there you basically set up things like etcd, kubelet, the API server network overlay, CA certificates, kubedns, etc. And generally install Kubernetes. And then once you have that, and basically you can use tools like Puppet or Chef or Ansible to achieve that. And once you have that, you get to the third layer, which is Kubernetes, which involves things like persistent volumes, replication controllers, pods, etc. And now many people have been using historically Terraform to manage the lower part, and you can still do that. But what I'm going to focus on today is the top layer. That's the API, the Kubernetes API. And obviously there is an overlap in every direction. There is no clear answer or like right or wrong solution why you should or should not be using any particular tool to manage any particular layer. But that's just to say what we're gonna talk about. So just a quick disclaimer, every company has different needs and workflows. So I'm not gonna try to convince you it's the only way to manage Kubernetes, because it isn't. So read that as that there is no silver bullet. As we dive into the content of this talk, I'm gonna cover HCL. That's the language that Terraform uses, the nature of the workload that you can and perhaps should run through Terraform. Then one of the benefits of Terraform, synchronicity. Why covering the full life cycle is probably a good idea. And then we're gonna have a look at where is the responsibility overlap between perhaps the existing tooling around Kubernetes and Terraform. And if we have some time left, we're gonna get to demo. So HCL, so-called HashiCorp config language. Is anyone familiar with HCL already? Yeah, a few hands. So HCL, even if you're not using Terraform to manage your infrastructure, if we set the manual management aside, because that usually doesn't scale, you would be building your own scripts using a high-level language like Python or Go. And that means you would need to deal with all of the idiosyncrasies and nitty-gritty details of the APIs, and generally use an imperative language. And at the end, you would probably ask for some help from the data languages like JSON or YAML, because hard coding all of the details of your infrastructure in a programming language like Python or Go doesn't seem like a very scalable model. And those languages on the left side, like Python or Go, offer you plenty of ways to shoot yourselves in the foot. They have classes, functions, for loops, etc. Whereas on the other side, data languages, because they were designed to transfer data, they don't have any of these features. So they are very much simpler. But they also lack features that you may find useful when describing infrastructure, like referencing or comments. I mean, you can do referencing in YAML, but have you ever tried to do that? If you tried, then it's probably not a great experience. So that's why, despite that designing a DSL is a challenge, that's why Puppet and Terraform have chosen that path. So HCL is a separate project which you can find on GitHub, and it is used in various HashiCorp projects like Console, Vault, Nomad, or Terraform. The nice benefit of HCL is that it's JSON compatible, which is useful for generating code. You may ask, why would I want to generate a code? So one of the reasons, well, here is an example. It's a repository managed by the GDS. It's a government digital service in the UK. And they take advantage of this in their solution for DNS management. So they take their bind zone files for DNS, they convert that over to JSON, and then hand it over to Terraform, and Terraform creates DNS records in GCP, Google Cloud Platform, Dyn DNS, and Route 53. So that's how they manage their DNS to ensure sort of the redundancy. Now, coming up, workload. By the way, if you have any questions in the meantime, feel free to raise your hand and ask. So what kind of workload, Kubernetes workload, is best managed by Terraform? So the Kubernetes provider today supports, I think that's 13 resources and 2 data sources. And it's a long list, but those are all V1 resources. And I'm going to cover the sort of alpha and beta later on. So there are some ops-focused resources on the list, or resources that would be typically used by operators rather than developers, which involves config map, limit range, resource quota, secret namespace, which allows you to sort of scope down your workload or service accounts. Yeah, in case, yeah, I'm hoping that most of you are kind of familiar with this. I don't need to go too much into detail of what each of these resources mean. So operators are already likely familiar with Terraform, and they are responsible for bringing up the clusters. So this is why it's a good fit. Now we come to ops workload. There are some workload resources like pod or replication controller, which basically replicates pods, or horizontal pod autoscaler, which tells the replication controller how to replicate the pods, or the service, which exposes your pod to the internet, to the users basically, or to other services. And while you could use while you could manage those resources as a developer to schedule your application workload, I wouldn't recommend you do that. Instead, I would suggest that you only leave these resources for ops, and the reason for that is because Kubernetes has this concept of admission controllers, where the controller which sits in Kubernetes can intercept a request for the creation of the resource and modify the resource and give it back to you in completely like modified, and it looks completely different. And that doesn't play very well with the way Terraform works, because in Terraform, whenever it tries to create a resource, it expects the resource to come back in exactly the same state. And it is kind of a feature of Terraform to detect any drifts whenever someone modifies the resource outside of Terraform. So that's why I'm suggesting that it should be operators who use these resources, because those are the people who are familiar with any admission controllers that may be in the cluster. So that's workload. Now synchronicity. Kubernetes API is designed to be asynchronous, which enables scalability. So that's great, right? And Kubernetes always expects you to be sort of proactive about asking whether an operation has failed or finished generally, at least initially. But not all failures are retriable. So let's have a look behind the scenes for a moment. This is a config that, let's see if I can use this. Yay. So we have a resource here. It basically describes a pod in a Terraform config. This just says that it's a pod. This is a reference name so that you can reference elsewhere in the config. This is the actual name that gets submitted to the API. This basically makes doesn't read, that's just for internal reference. So that's the difference. And this is the spec of the pod, where we say we want to launch nginx 1.7 and the name of the container. So now what really happens behind the scenes, though, is that that Docker needs to pull down the image and start the container, which takes time usually. And as you can see, we have a typo here. And if you have a typo, do you really want to, you probably want to know that you made a typo. So a single container failing because of lack of capacity probably doesn't matter unless it's the only one. So if you fail to launch that container and it's the only container that you have in the pod, then it's probably a problem. So that's why, oh, actually, let me do the comparison. So this is how you create a pod in kubectl. You basically call kubectl create and the YAML definition of the pod. Then you ask for the status of the pod, because again, as I said, you have to be proactive. And then eventually you ask the events API, what's the current status? Why is it actually failing? Has it finished yet? Why is it failing? So you gotta ask for that. And in case of Terraform, what we do in the provider or in the resource is that we poll the API periodically for some amount of time, and we give you the reason why it has failed. So you don't have to do all of that sort of hard work. So now obviously I'm gonna cover the differences between replication controller and pods, etc. And in which case you would see the error. But in this case it's a pod. So as I said, if the single container in the pod fails, then it's a failure. So this is how you create a service in kubectl. Again, you pass the YAML config, then you ask for the status of the service, because the service needs to create a load balancer, and it needs to wait for the external API to come back from the API. So that takes some time, obviously, and the provisioning may fail as well, because you may run into limits, some quotas that your cloud provider has in place. And you would be checking the API again to see what's the current status. Here we would see that it has failed to create a load balancer because we have reached the limit of static addresses in GCP. So it may happen. Failures do happen. And once we bump the limit, then we can we basically still need to wait for Kubernetes to reconcile and until it returns us the hostname or the IP, so that we can reference it elsewhere, which you can do in Terraform fairly easily. So here is an example of a config of a Kubernetes service. Again, fairly simple. What's different here, or what's new perhaps for you to see, is this reference syntax here. What that means is that basically draws a dependency between Kubernetes pod and the service, and it says create the pod first, and once you have the pod in place, once it's been created, then give me the app label and use it here. So that's the reference syntax. And then we have the port forwarding below, and we set the type to load balancer, which means the service will be exposed through a load balancer. And then that's the benefit that you get. You can reference the service, the load balancer that comes out of the service, which was provisioned by Kubernetes. You can reference either the hostname or the IP address in a DNS record in Route 53, for example. Terraform will wait until until Kubernetes has finished the provisioning of the load balancers, so that you can get the IP or the hostname and create the record, because you can't create the DNS without an IP or the hostname. So how does Terraform create a service? You run apply, and eventually it may time out. I know the colors are probably not great, but it works the same way as pod. So if it fails, we query the event log to give you the reason of why of the failure. That's what you get. Now here is a successful service creation in Terraform, where you get to see the ordering. So once we run apply, which means Terraform takes all of the configs and it sends all of the API requests in the right ordering. And you can notice that here we start creating the service, and it waits for the service to actually finish the creation, which happens here after about a minute. And then after that, we start creating the DNS record, and we use the IP address, which was pulled out of the service in here. But we didn't really have the IP address until this point. And then eventually we finish syncing the DNS record. So, full life cycle coverage. Why covering the whole life cycle is probably important or useful? Well, because every app needs to be created, updated, and will be eventually decommissioned, because app is not done until it's decommissioned. So many folks believe that this is the path to production. Like, we just create stuff and that's done, right? And in fact, you need to keep updating it, and one day you need to delete it. And the nice benefit of Terraform is that you get the full, you get one command to apply all the changes. It doesn't matter if you're deleting or modifying or creating resources. Terraform will try to figure out what needs to happen on the API level based on how you change the config. So we will hopefully see that in the demo, in more practice. And it's always advisable to see the plan, which basically tells you what's going to happen before it's actually going to happen. So yeah, that's the full life cycle. First we create, then we update, and we can delete. But whether the resource is updatable often depends on a field. So in case of a service, not every field that you can see here is mutable field. So in order to know which field is mutable and isn't, one has to read the docs carefully or hope for the best. So here is an example of updating a mutable field. That's the selector, which can be mutated. So you get to see that in the plan. So it's all in yellow, which basically means, yeah, it's fine. You know, Terraform's saying I can modify that without an outage. It shouldn't be. Whereas here you can see a different change. Cluster IP, which isn't mutable field. You can't just change a cluster IP. So in order to change the cluster IP, Terraform needs to recreate the resource from scratch. So that's what it says here. It says first is new resource, and it basically tells you, hey, something may go wrong eventually because you're going to delete the resource and there won't be any resource for a short period of time. But the good thing is that you know this ahead of time before things actually happen, before you run apply. Now let's talk about where we draw the line between Kubernetes and Terraform. Yes.
Can you use option create before delete on Kubernetes?
Yes, you certainly can. So there is a what happens. What would happen in this case if you had the config that we've seen here, just as is, it would first delete the resource and then create the new one. The reason Terraform does that is because your resource may have a unique name and it can't create the new one before deleting the old one. But if you already know that you use unique names, randomly generated, or at least some suffixes or prefixes, then you can use the lifecycle stanza in the config, which basically says create before destroy, which is what you're mentioning. So that's available to any resource throughout all Terraform, all providers, everywhere, which basically says reverse the ordering and first create the new one and then delete the old one. And basically after it creates the new one, it will also update all the references and then delete the old one. So that's the sort of non-disruptive way of updating it, I guess. Does that answer your question?
Yeah, thank you.
If you have any questions, just don't be shy. I'll come.
So let's talk about the line between Kubernetes and Terraform. There are 4 main areas where you may see the overlap. So just because you can do something in either Terraform or the kubectl or any other tool doesn't mean you always should. Annotations is one place. And it's Terraform's expectation often that, as I said at the beginning, what you submit to the API is what you get back. Or at the very least, it's clear what aspect of the resource may change over time. But that's not the case for internal Kubernetes annotations. Kubernetes has these annotations, which begin with kubernetes.io. And in Kubernetes world, these can be used to enable alpha or beta features, but they can also be attached by Kubernetes, the kubelet, to enrich some resources. Like, for example, to say what region or zone am I running in. And so there is no clear line between what's user-defined and what's Kubernetes managed, which makes it quite hard for Terraform to figure out the difference. during the plan stage, which is why we ignore these annotations in Terraform. However, there is demand for internal annotations, so we're gonna need to figure out how to. We're gonna need to revisit that decision and figure out how to support that. So container workload is another area of overlap, and you may run a static app in a single pod. Excuse me. And you could schedule the standalone containers, but that's Terraform's Docker provider. So if you use Terraform Kubernetes provider, you could use Terraform to schedule the pod. And then within the pod, you would have those containers which are completely managed by Kubernetes. So Terraform doesn't care about any container that runs within the pod. That's the responsibility of Kubernetes. But in this case, Terraform can provide the initial feedback. Initial means when you first create the pod, because you probably, if you're creating a pod, then you want to know if it's actually running. Now we get to see more dynamic app where we can control replication controller through Terraform. And here Terraform schedules the controller and leaves pod and the containers to Kubernetes. So again, Terraform only cares about the controller and leaves pod and containers to Kubernetes. And it wouldn't even make sense to deal with pod failures at this, because you could have so many pods that just failures are expected on that level. So we don't try to mess up with that. And then you get even more dynamic, where you have those horizontal pod autoscalers, where you define the minimal and maximum number of pods that needs to run in the replication controller, which also needs to be managed by Terraform, because doesn't need to, in this case it probably should be, because you get to define the initial number of replicas, and you need to reference it in the autoscaler. And there is a bit of overlap, because you need to define, as I said, the initial number of replicas, and then let Kubernetes manage the runtime, which means pod and containers. So one way to deal with this overlap is to use this lifecycle block that we talked about. Other than create before destroy, it also has this other config option here, which is called ignore changes. And what we say here is, create me a replication controller with 3 replicas to start with, and then whatever changes happen to it, I just don't care. Like, just ignore any changes that Kubernetes makes or anyone else makes to that field here. So don't generate any diffs. So that will prevent the conflict. Now, volumes can be managed by Terraform. By volumes, I mean EBS or Google Cloud persistent disks. That's been always the case. But whether you want to use Terraform to manage those depends on your workload and trust between your operations team and the dev team. So more commonly, people who run Kubernetes are a bit more relaxed in the relationship between ops and devs, and they demand easy scalability. So you would let the storage class in Kubernetes to be managed by Terraform, and then the storage class in Kubernetes would provision the EBS volumes or PDs on demand, effectively. So you would just tell what kind of storages do you want. And you could do the same with persistent volume, which basically does the same thing, or persistent volume claim. Or even a pod, which may be a standalone pod, or a pod that is scheduled as part of the replication controller. Now you can manage load balancers directly in Terraform and turn all the knobs there, but that may not be as convenient if you have more dynamic workload, where in Kubernetes your services just come up and go away very often, and you need to have them under the load balancer all the time, and you need to have a load balancer per service. So in such case, it's probably more sensible to leverage Kubernetes for the ELB and Google Cloud load balancing, and then only let Terraform talk to the service, to the Kubernetes API. So we are pretty much near the so we get to see the demo, hopefully find it. But yeah, before we dive into demo, if I find it, we have us in the demo. The first one is developer Bob and operator Alice, and we're gonna build an on-call app. So Bob, who is the guy on the platform engineering team, he's gonna use Minikube. That's the sort of minified version of Kubernetes, which you can run in VirtualBox locally. And he's going to leverage the replication controller and the service. So let's see if we can oops. Any questions in the meantime?
Any questions? Just to fill the pause.
It's too many things. All right, let's see. Can you see that? Can everyone see that from the back? Yeah? Cool. All right. So let's see if we have any existing state. In fact, let me see if we have Minikube running. That's safe, that's not running. So Minikube start. Start Minikube first. That's why this isn't working. And eventually, when it starts, we're going to be able to schedule something. In fact, I should perhaps spin up the GKE cluster as well. Okay, that's coming up. Yeah, that's still hopefully running. That's not running. Do I have oh, that's because I don't have internet here. That might be why. Does anyone know how do I connect? Oh, okay. Spot public. Oh, it goes to the recording, right? I shouldn't say that. Right. Okay. All right. Here we go. That's better. Okay, so we have the cluster running. Now we have Minikube running. Yay. Now that we have Minikube, let's see if just destroy anything that I had here. And start from, just let's review the configs that we have here. So we have the provider block here, which in Terraform basically says how to connect to the provider, which in this case is Kubernetes. Here we say which config context to choose. In this case, it's Minikube, so basically connect to Minikube. Then we define the controller here, and we give it some labels so that we can address the pod through the service, so we can direct the traffic. And then here we use our special service. We give the container a name, so this is like basically the Docker image, which we pull down off the Docker Hub. And then we specify some resources, limits in this case, so how far we can get, and then how much do we request at first. And then we have the service defined here, which in this case we use the cluster IP type because we run on Minikube, as I said before, so we don't have the load balancers available there. So that's why we have to just do simple IP forwarding. And then we also output the service name, which is very useful for either for the user or for someone else that may be leveraging your configs elsewhere. So let's run Terraform plan. And in this case, you can see that's fairly simple plan. Only 2 green resources, 2 to add, because there is nothing at the moment. I'm just going to run Terraform apply. And yeah, eventually, if I did not have, let's pick another one. Okay, here we go. And now what I can do in Minikube, there is Minikube service, I think it's this way, Terraform output service name, like this. And that will hopefully bring it up. Maybe not. That should bring it up in the browser, unless I'm mistaken. List, let's see what list does. Yeah, I just did specify service list. Right, that's the list, and the name of our service is this one, so that exists. I don't know why is it not coming up. Oh, dash URL, let's see. Maybe that goes here, actually. Nope, that's just demo gods here, in effect. Anyway, I can hopefully... no node port, that's right. I should probably read sometimes what it says in the terminal, right? Yes, we don't have node port. So we need to define the node port, and let's see what the documentation says, which actually I wrote a while back. As a service. So node port, yeah, that's in the port. So let's allocate node port. Let's give it a high port, 20, something like this. Let's see. Terraform plan. Okay, we can change that. But it needs to be a different type, which is node port, I assume. Yes. That's why. So I think it can actually allocate the node port itself. I just have wrong type. Let's see. Yay! Yes. So this is the on-call app. It's the very first iteration. You know, the next one will have some PagerDuty integration. Now it just says I'm on call. We'll get there eventually. So that's the first persona. So Bob's done with his work, and now we coming up is Alice. And Alice has chosen the GKE cluster because because she's an operator. So you know, GKE is the hosted Kubernetes service from Google, where they manage Kubernetes master for you. So it's much easier. And she's gonna create some namespaces and limit ranges. So let's see. So we have the infrastructure. The cluster is already running because spinning up the cluster takes a few minutes, and I personally like watching the terminal and waiting for things to happen, but I gathered that not everyone's like me, so I just did that beforehand. So let's see. So this is what I've done before. Here we have the Google container cluster. We have, do we have the provider anywhere? Yeah, that's in a separate file. But we don't need to see that. Here we have just the container cluster. We give it a name. I usually like to name my clusters in a way that it scares everyone away, so they don't delete my cluster. And then then we just generate the username and password and give it some permissions and output the zone and the cluster name. And now the nice thing about gcloud CLI is that you can basically get the credentials for the cluster like this. So Terraform has this nice command that's called output, which basically lists all the outputs that you have defined in your configs, like here. Or you can reference any existing resources and stuff. So maybe just to explain for those of you who are not familiar with Terraform, this basically means go and look for a resource that's called like this. There's a type of the resource, and then the reference name, primary in this case, as the second after the first dot, and then the last one is the field name. And we expose that in here, so you get to see that after apply and in here Terraform output. So we hopefully have, let's see, kubectl. Let's see if we have access to the cluster. Was it list nodes? Oh, get nodes. kubectl get nodes. Hopefully. Yes. Okay. So kubectl can talk to my cluster. That's good sign. And now we can get to the meaty part, and those are the Kubernetes configs. So here we have Alice runs the cluster, so she points her provider to the GKE cluster, and she creates a namespace, gives it a name, and then she creates a limit range, which basically says how much resources can a given pod scheduled in this namespace consume. So how much CPU and how much memory. So that's how operator can define boundaries within the cluster. Oh yes, and this is so basically I now need to download the Kubernetes provider, but since I already have that locally compiled, it doesn't actually do anything, but it just records the hash. So this allows us to actually ship. This feature came out in the recent major version, the 0.10 of Terraform, and that allowed us to, instead of shipping one giant binary of Terraform, we now ship each provider separately, which rapidly increased the speed in which we ship new releases for every provider. So we don't have to ship like a whole giant release just because AWS was so active, the AWS provider. So now we have Kubernetes provider in place. We can run plan, and again, that's a fairly simple plan plan that we can review. You also get to see all the defaults that are not visible in the config. That's quite useful. It says that this will be computed after the creation, so you can reference things like UIDs or IDs and things. Yes, so Terraform apply. Let's do that, and that's done. So what's next? Production. So we have production. You know, want to go live. Let me actually destroy this first. So what we have here now, because Bob and Alice came together, they said, "Oh, our configs look very similar, but actually they are quite different." So what they need to do is to make sure that these configs are reusable, and one way to do that is to use workspaces and conditionals in those configs. So they agreed that they're going to use Minikube locally to test everything before it goes to the GKE cluster, and so they're going to use separate workspaces. Even if you have never used workspaces in Terraform, you are already using workspace, which is just called default. Now let's see. Yes, obviously list. I'm just gonna select default, and the reason workspace is so that you can separate out the state of your infrastructure, in this case Kubernetes resources, so that whenever you can see that I deleted those resources previously, but in fact you can see that they exist here. You can still see that it's refreshing. So I'm gonna destroy this again, but it looks like I'm doing the same thing, but in fact I'm destroying those resources in Minikube now, because previously I was in the prod workspace, which was pointing to GKE cluster. So now that I'm in in the default workspace, it means that in this config here, this conditional here is basically choosing the Minikube context out of the config, and if not, which is the prod workspace, it chooses the GKE cluster. And then we have, that's all the same business here, and we also have one other difference. That's how we launch the service, because in GKE we get to leverage the load balancers from GCE, and we don't have the chance to do that in Minikube. So that's why we have this other conditional here. So let's see. So now we are in Terraform workspace list. We are in default. So that should work pretty much the same way as it did in the first demo. But let's see if we oh, right, that's because obviously my kubectl is pointing to the GKE cluster. So I would need to this credentials something. There's kubectl subcommand for managing credentials and switching the context, which I obviously don't remember. Does anyone know offhand? Get context is one. Config.
Yes.
Yeah, get context. Like that? Like that? Awesome, thank you. That's why it's useful to have. That's the one. Awesome, thanks for the help. You're gonna get the sticker. I have a special sticker just for St. Petersburg. So Minikube service Terraform output service name. Yes. Isn't that awesome? And now we get to launch that on the GKE cluster. So we just switch the workspace and select prod. Now we switch the workspace, and as you can see, the type is load balancer in this case. Wait for the load balancer to actually finish provisioning. So this will take a while. It will definitely take longer than the previous run because we are waiting for the GCP load balancer to finish the provisioning. So there is time for questions. Or we can just carefully watch the terminal. I like doing that.
So, yeah, I see Taras.
Hi, actually I have a question not about Kubernetes and Terraform, but purely about Terraform. I wanted to know what new features are you planning to add in the near future, like in maybe 0.11 version, something cool that we can use and that will...
So as I mentioned, and as you probably already know if you're familiar with Terraform, there was the provider split. So if we are talking about core of Terraform, where the next major version is 0.11, there are some things coming up. I'm not sure I can say that on the recording, but we are, let's see how I can say that. We are well aware of some shortcomings of the language used in Terraform, that's HCL. We are hopefully going to address that very soon, or at least some of the shortcomings. So that's one area. I'm not part of the core team specifically. We have two people who work mainly on the core stuff. That's like Terraform's core. I'm mainly focused on AWS, so I can talk about AWS provider because we also schedule some work per provider. And the way it works in the provider land, at least for me, is that I basically take all of the PRs and the issues, rate them, sort them by number of upvotes that the community has given us, and then focus on those. So anything, if you do that, you would see what's coming up soon. That's the way we do it.
Yeah, and that's a great hint to influence about for upcoming releases, just to post your issues to the community, and it will be in the upcoming release.
Yep. So we can see that it's running on the GKE cluster as well. This is the IP address of the public load balancer. So you should be actually able to open that up in your browsers as well. So that's I think that's near the end. Yes. Let me just do 2 more slides and then I'm done. Right, alpha or beta, as I promised. The Kubernetes provider currently supports all of V1 because it was just safe to implement for us. And we received many requests for alpha or beta resources like deployment or ingress. But the problem with alpha or beta is that there is potential for breaking API changes, and we need to figure out how do we deal with those without impacting the end user too much. So I'm aware that both Google and the Kubernetes community perceive alpha or beta differently to many other communities, and the APIs remain there for a fairly long time, and I respect that. And in fact, I thank Google for being so upfront about this. And I think the Google team that works on the GCP provider for Terraform came up with a fairly good solution in that area. So we'll probably apply that approach in this Kubernetes provider too, eventually. So to sum up, um, use DSL to your advantage because it's there, so you don't have to deal with YAML. This is a mainly ops-focused provider, so be careful when running pods and controllers and things like that, and especially when running application workload through it. And think about your culture and workflows first before touching the configs, and be aware of who is in control of your Kubernetes resources and avoid the overlap if you can. So that's it. You can, if you want to have any issues or send the PRs, then you're certainly welcomed to do that in here. And that's the end of my talk.
Thank you very much, Radek. So I propose to make a short break, and then we'll just return back and have some kind of discussion. So right now we've got 25 minutes past 8, so let's about half an hour, and then we'll return back. No objections? Okay, great.
Hello, do you hear me well? Guys, immediately after this Q&A session, we will there up to the 10 p.m. And after that, I might suggest you to move in and proceed further in after party. It will take place in Mannequin Peace. Do you know this place? It will be Moskovsky Prospect 198. So guys, I am wondering if you might join us and we'll be on the after party. Okay? Yes.
Let's make it a little bit interactive. So who will join us? Raise your hand. 1, 2, 3, 4, 5, 6. For sure time. Okay. Any other guys? Yeah, I see you. I remember. It means yes. Okay. And one more thing before we start our second part. It's very valuable for us to get a feedback from you. So feedback forms are on that table. So when you have time, please just step it nearby, and there is a lot of pens and forms. Just form it where we really need what themes are actual we are working on, and because we need to select to define a contact for our next meetings. Thank you. So to the second phase, I heard a lot of pretty much questions about Terraform in general in the break. So yeah, so we can just make okay, let's start from question and answer, and then maybe just transform it to something else. So who will be next? Timothy. The most farthest one.
Thanks. Radek, I have a question about a recent issue in the AWS provider, right? In Terraform. So this issue is about spot instances. You're probably well aware of it. Yeah. Is there any plan to fix it in the near future? More specific about the issue. Yeah, of course. So as far as I understand the issue, when the provider is used to launch spot instances, and in the process of usage, the spot instance price has changed, and the spot instance is shut down, then Terraform cannot perform any other actions because it sees that the instance is not available anymore. And basically, when you try to, say, apply some differences, they don't work anymore. So, and Terraform throws an error when trying to apply a right plan. So this is basically what I know about the issue.
Okay, thank you, Timothy and Radek. So who's next? I know. I see. Lev.
Could you please clarify why your team use Go for developing Terraform? Any reason? Is it historical or something else?
Why do we use Go
Yep.
for Terraform? So I wasn't around in HashiCorp when the decision was made, but I think it was a safe bet for HashiCorp to bet on Go. We use that for pretty much all open source tools except Vagrant and except some of our enterprise projects. And one of the reasons, there's a couple of reasons why we use that. Everybody has different reasons, obviously, but my reasons would be easy cross compilation, so statically compiled binaries. Then you know fairly simple, easy to follow syntax, which is much more difficult to write bad code in Go, in my opinion. You can always write bad code, very sort of dirty code, but I think it's much more difficult. I like the fact that you know in Go you can't even compile the code until it complies with certain things, like you know quite. It's very similar to Python in some ways because in Python you also have white spaces in certain places. It's part of the syntax, which I like personally. What else? Let's see. There are things I don't like about Go, obviously, but you know, out of the all, it's good about like good. Go has very good mechanisms for dealing with concurrency and you know how to like run certain things in parallel, which we leverage in Terraform. So when you see the output from FI, when it's doing all the you know sending all the API requests, then we can parallelize all of the API requests and do it very efficiently. So it's very efficient. It does very efficient garbage collection as well. I don't know what else. It's probably half a dozen of reasons.
In general, it's clear. Also, I have one more question about HCL. For you have JSON. Why your team use HCL? One most on that, it's not really good idea from my side.
Yeah, I thought I explained that on one of the slides.
Oh.
So what solution would you choose, just so I could?
I think that it's possible to use JSON to describe to describe the same things. Why?
Yeah, you can't have training commas, and more importantly, you can't have comments in JSON. If you get to build out your infrastructure and it gets very like larger and larger, and you get into templating, then you realize that JSON is like you can use JSON, but your configs
Okay, thank you. Let be Alexei first.
Thank you for Terraform. I would like to ask you about VMware support and if it will be official for some time.
Yes, so so I think it's 1 or 2 months ago that we hired a guy from Canada actually to work just dedicated, like be dedicated to VMware and vSphere. I think I'm not that familiar with VMware planned, but I think there's a couple of different VMware APIs, right? There's the cloud director and vSphere and maybe something else. I don't know. But I know he's focusing on VMware, and I think we are going to make it sort of officially supported. I think that provider should eventually reach 1.0 as well. That's like we started bumping most of the providers to 1.0 just to acknowledge the fact that we follow semantic versioning. But there is a few exceptions, and VMware is one of them because we don't want to tell people that just go and use it in the wild because VMware will need to go to some significant breaking changes, I think. And it's probably there's a lot of missing functionality there. That's as far as I'm aware. I'm not that involved in the VMware provider, so yeah, we certainly have an employee of HashiCorp working on VMware.
Is VMware supporting?
That would be great if it did. So we have partnerships with many vendors like AWS and Google. So Google supports us very well. They basically have 4 full-time employees, like Google engineers, that work with us on HashiCorp tools. So 2 that work on Terraform only on the GCP provider, and I think 2 others that work on Vault, which is the GCP or the Kubernetes integration with Vault. So we have partnerships with many vendors. I don't really see too much into the details of other partnerships, but it would be great if it worked that way.
Okay, thank you.
Thank you for your question. So let's move on.
Okay, hello. So you've seen how like the management of multiple Terraform clusters is inconvenient. So how the Kubernetes clusters is inconvenient. How Terraform can help like me manage many clusters and basically copy them between like so I have several copies of one infrastructure on different clusters or something like that without any like manual kubectl switches or something like that. Like basically specifying like an array of Kubernetes resources.
That sounds more like Kubernetes question.
Yeah, well, not counting the federation of Kubernetes.
I don't have an answer to that honestly, because even though I was part of the operations team before for a short while, we didn't really run a Kubernetes cluster in production, so I don't know how familiar with that. So I don't really have an answer.
Okay.
Okay, who's next? Taras. One more question from Taras.
First of all, thank you. It was a very good presentation, and I have a simple question: how we should manage sensitive data like passwords in Terraform, and if there any changes about it in the future?
Right. So just to give some background to others, if you have any sensitive data in your configs, then basically what Terraform does as it applies all changes, it records the state of the resources so that it can reference the IDs and knows what to update in the future. And that state is by default saved locally, but you're encouraged to store it remotely if you work in a team.
to have several state files.
So there are ways you can reference the state files as well.
And are there any plans to do something with it in the future?
Yes, we certainly discussed this, and we want to address that. But it's, as far as I'm aware, it's not on the nearest, like, few months roadmap. There are some other more important things that are on the mid-term roadmap.
Got it. Thank you.
Okay. I know Ilya has a question. Roman has a question. Okay, Ilya, a couple of minutes for you.
So actually, Radek, I have asked this question you previously. If you deal with multiple environments, and you mentioned workspaces, yeah, and I didn't remember conditional checking, or how it's actually called, when you, for example, you have one definition by default, and you set this variable, and for example for prod you will stay and choose this one. And if you have more than two environments in real environments, in real infrastructure, how it's better to deal with it? Previously we used tfenv. It's another open source solution for switching and dealing with multiple states file and other things, but it's not so good to write the same code 4 or even more times. Maybe here is the best solution.
So I know that
Let me, yeah. And another question: if we are dealing with multiple accounts in AWS, and for multiple enterprise companies they have more than one AWS account, how it's better to switch them and have similar infrastructure across different accounts?
I think you can use the approach that I just
Okay, thank you. So yeah, now it's your turn.
Hi, I have a couple of questions. First of all, if we have split configuration of Terraform, as an example, we have some core states in one project like VPC, subnets, security groups, etc. And other projects like small environments, couple of instances, Elastic Load Balancer, and we have two remote states in this environment project. One remote state for the core project and one remote state for this small environment itself. And for example, we would like to test some new Terraform version. And when we make plan, will Terraform rewrite to Terraform remote states as in for the local project as for the core project? Is there any way to test this without breaking the core if we would like to roll back?
I think until very recently, plan was because plan does a refresh as well. Plan was changing the state file, but that's not the case since 0.8, I think. So you can run plan. You should be able to run plan safely without modifying, so it doesn't modify your state. Which means because we record the Terraform version of the state as well, which basically which means that once you use the new version of Terraform on that state file, you can't downgrade unless you manually
Yeah.
modify it, which is generally not a good idea. So is there a way to test that safely? If you have a dev environment, which generally should have a separate state file, then do it that way. I don't know if that answers your question, but
So as I understand, if I try apply, then Terraform will update TF state file for both for the environment and for the core.
no, Terraform since 0.8, if you have any version that's past 0.8, I think that's the default version, then plan won't make any changes in the state file. It will only display you the plan, and it will generate the plan on the fly in the memory. It will generate the plan and the state file. But only once you apply that plan, then that will be recorded back to the state file, and the new version of Terraform will be also recorded back. So yeah, I think though that there should be less and less reasons why you would desperately need to upgrade Terraform as in the core, because since the provider split, the more common reasons why people would do any upgrade in general is to get more features that you release in the provider. And that you can do fairly safely, I think. So I don't think it even gets recorded in the state file, like the version of the provider. So you can upgrade providers fairly independently from the core. So if you're keen on upgrading providers, then it should be fairly safe.
Okay, we'll test on new Terraform release. Maybe second question. We have modules that stored in Git. We have modules that store in Git, and in some project we use this module couple of times. As an example, module that describes how instance should be deployed, and we deploy a couple of instances using this module. The problem is, if I change this module, I have to to apply changes to this project. I have to remove .terraform directory, run terraform init. For each module usage, I have to type username and password for the Git, and only after then that I could make a plan. And even if
So could you, I think that's more of a generic problem when you're dealing with Git repositories in any way, like anywhere. We use GoGetter, which is our internal HashiCorp library that we wrote and use in the Terraform environment where to pull down, to basically take any kind of URL and pull down the contents from there, like where it's stored, where it's linked, and then where the PC, etc.
Yes, you're right, and I tried to add to the source. How do it's called? Wow. No, no, no. Source doesn't support variables. I could solve this problem just by adding to this Git URL username and password by variables. So in the plan, I'll be asked to type those two variables. I type them, and the build completes. Um, we could not use SSH as this could not be approved by our security managers. So Git and SSH is not okay in the security concerns. I could say UI. No, 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 no. As an example, you have Git project that is accessible via SSH. So all users that access this project are accessing it by using one user, SSH user. And this SSH user on a Git just have authorized key file with all user keys. So they are all logging to Git via SSH using one account, but different keys. So just one user can. Not exactly. Sorry, don't understand. Could you repeat, please? Only one. But by design, we just bought company. They have Git installation, and that was the way that they work. They have a lot of tool set that could work only with such a Git. They have one account, one Git account, and multiple their personal accounts with keys. And this Git account have those developers' keys in its authorized keys. So each user connects to Git using his own SSH keys. But on the Git, the user is always the same, the one. SSH session is the one. That's why this configuration is not secure. No, no, no. Yeah. But this of Git usage doesn't mean doesn't follow security compliances that we have to follow. Just that's why we could not use for in Git. So in our company, SSH keys are not allowed.
Okay, that's I think definitely a tough case. Maybe that's why they were purchased. Things are very complicated in this. Taras has one more question. Maybe anyone has any question? Yeah. Okay, new one.
A pretty simple question. Is all this feature ready for real production and security API that Kubernetes introduced in version 1.70 about RBAC and other security groups and users?
Are you talking about Terraform?
I'm talking about Terraform with Kubernetes. Can I describe this API about users and security groups via Terraform?
Now you're talking about users and security groups and Kubernetes provider. How is? I don't get the connection.
In Kubernetes, as far as I know, there RBC, role-based control.
That one.
Yeah.
That's not. Is it part of V1 yet? The RBAC.
It's in official release 1.70.
Yeah, I need to take a look into that. Yeah, I don't know if you can use that with RBAC. I know there are some resources which we need to support, which certainly aren't in V1. Like you need to create the association between the role and the cluster, or the user and the role, and things like that. And those resources aren't V1 for sure.
Okay.
But we want to support them eventually. As I said, alpha or beta, it should be supported eventually, but it's just a bit more work.
So your team working on to support latest Kubernetes API as far as as fast as possible. Okay, thanks. And
if there is, we need to come up with a good framework. We're probably going to use the same framework that they use in GCP to support alpha or beta resources, because you basically need to talk to a different API once you use the beta features or the alpha features, and you need to make a distinction without breaking the experience for the users that only use V1.
okay, thanks. So I understood. And now my question is: this ready for real production, or maybe? And be careful.
So it depends how brave you are.
Okay, thanks.
So I think generally speaking, I know about companies who ran Terraform since 0.4 in production. They have strong engineering culture. They have good operations teams, and they just run with it.
Okay.
Because they recognize the advantages and the value that Terraform gives them in the workflow and everything else. They just accept the missing bits and pieces and the bugs that may be there, and they just get on early. So if you're that kind of, if you have that kind of team with that kind of mentality, then go ahead and run it in production. But if you're looking for something a bit more like battle tested, then it's probably not the right time yet.
Oh, okay, thanks. I understand.
So we certainly welcome people to test and report bugs and ask for features. And yeah, that's all I can say, I guess.
Thanks.
Taras, I know you have a question, but let's ask another guys who hasn't asked yet. So, you have a question? No? One more from Ilya. Okay. So just keep the microphone closer to your mouth. It will be.
Okay. Could you please say, maybe in general, what is the difference between enterprise version of Terraform and a community edition, and which benefits could we get by buying the enterprise? Could we get some support in complex cases where Terraform developers assistance needed to troubleshoot our configs. Is is this goal could be achieved?
Terraform Enterprise makes the most sense for bigger teams, I would say, because it offers some features on top of Terraform, like approval process and integrations with Slack, for example, like chat, and it gives you a nice UI on top of integrated with GitHub, basically. So whenever you merge, whenever you actually open a PR, it runs the plan for you, and it reports back that the plan was, as green or red as a status to the PR. Um, so it should be applicable without any issues. Then you can merge the PR, and then it runs the actual plan again from master in Atlas, and you get to do the approval, and you can comment on it in Atlas, sorry, Terraform Enterprise. What else do we get there? Yeah, you get the notifications in Slack as well. So whenever someone whenever someone merges the PR, you can actually approve it straight from Slack, for example. What else? You can have it's probably a lot more features which I can't remember.
Okay.
That's simply because I work mainly on the open source part. So it's just there is a team that works with us, but the enterprise offering is technologically different. So we work with each other, but like it's a UI job mostly. So it's like you get a really nice UI and workflow, which covers you from uh, from the beginning till the end, till production basically. So you don't have to build your own workflow around Terraform. You get you used to get the locking as well, which is now part of Terraform, but you might still need some kind of bits and pieces around Terraform to make it safe to use in bigger teams. So that's what Terraform Enterprise gives you.
Okay. We are almost run out of time, but we have time for a couple of more questions. So, anyone else willing to ask?
If you're interested to hear more about the Terraform Enterprise, or you're thinking about buying it, then I would certainly recommend filling out the form on the website, and someone will get in touch.
And as far as I know, one of your main office are in California, in San Francisco, so it's pretty close to your headquarters. So you just go and visit them. Nothing special. Maybe it will be the opposite case. They will visit you and describe Terraform Enterprise in detail for your operations director, for Dima, for example. So I think it's pretty easy. Okay, let me encourage you. So we've got special stickers for our meetup. So I will grant it for everybody who asked questions. So let me start, and other guys can think a little bit. So I know yours and you. Yeah. Sticker is most important. Yeah, but I can't see him. Yeah, this one was. Yeah, I know. And who helped you, by the way? Okay, will be the second one. So Timothy, it's for you. Okay, so anyone else would like to have a sticker? So
Anyone want Terraform sticker?
Yeah, and special Terraform stickers. I think everybody wants. Okay. Sergey has a question. Maybe the last one.
I'm just thinking about what will you describe a worst possible workflow for Terraform and Kubernetes?
Worst possible workflow. Wow. That's a good question. I mean, worst case scenario or worst possible workflow? Because workflow, I can think of one workflow. I can't think of a bad workflow.
Okay, bad will go to.
I don't know. The worst case scenario that may happen in Terraform in general is that you will lose track of your resources. But there is a way to recover from that. Well, first of all, you should store your state remotely. That's the sort of long-term solution for the future, so it doesn't happen again. But you still have tools in place to import resources back. So you can use the import functionality, which will basically record the state of the resource as if you created it with Terraform. That's all I can think of.
Okay, so looks like the time is up. We've got 10 or 15 minutes. So thank you for coming. Thank you, Radek, for for interesting question and for the great discussion. So let me remind you that it's really important for us to get a feedback from you, and feedback forms are over there. So let's say thank you for Radek once again.
Obviously, those are not as special as the St. Petersburgs.
Yeah.
But yeah, those are product ones. So still need to keep some for tomorrow. But if you're interested.
Yeah. So they also will be available there. Just to minimize your movement in this space. Radek will be one of the speakers in DevOps. Just a small announcement for EPAM guys. We've got a special remote translation for this remote. How to tell in English? Not translation. Broadcasting. It will be on the first floor in our Октябрьские office. So we will have a moderator. It will be Sergey. So I think 10 a.m. it will start. So maybe you will talk a little bit about details about the translation. No? So anyway, DevOps will be available in remote broadcasting in EPAM office, and feedbacks are still there. So thank you very much for coming. We really need your feedback for further valuable meetups. Thanks a lot. Let me remind you that we've got an after party in a pub, so everybody who's you are too strict. So the address is Moskovsky Avenue 198 at Mannequin Peace Pub. So waiting for everybody.